All right. Hello all. I'm Mikko Keskitalo. I'm the CTO of Profilence, and I'm really happy to be here. I've heard some great, interesting presentations from our colleagues and had very interesting discussions as well. It's actually my second time here. I was in Detroit as well, but I have to say I kind of prefer Berlin in June over November in Detroit. And I'm joined here by my friend, colleague, and comrade in arms, Marius from P3 Solutions. And we're here to talk about software quality, and primarily about software quality in Android automotive infotainment systems. So we're going to split this in two parts. I'll first talk about theory with a few examples, and then Marius will present kind of more concrete examples and findings on a recent project we've been collaborating on. So a few words about Profilence, the company. We're based in Finland, and we specialize in finding kind of the long-term effects and stability and performance defects from, especially from Android systems. Our background is in smart devices, medical devices, secure communication devices as well. And what's kind of drawing us into the automotive industry is the fact that Android seems to be getting more and more commonplace. And we have a very good out-of-the-box offering, especially for Android-based systems. We've been working with various kind of Android devices for over 10 years so far. So what I'm going to do next is I'm going to talk a bit about different kind of categories or archetypes of issues that we've found in various customer projects. So that should give you a pretty good idea of what kind of problems we're usually trying to find out for. First of all, case one, memory leaks. So I won't go into too much detail into what is a memory leak, but essentially all software systems and apps need memory to work with. And if they don't get enough memory, usually bad things happen. Usually the process or the application will crash or be killed by the system. Now, a memory leak then is the fact that somebody somewhere unintentionally wrote a piece of code that makes a certain action, especially, for example, on the HMI, to consume a bit more memory every time something is done. And if that happens, then eventually that process or application will be denied that memory, and then that typically manifests as a crash. So in this particular example that we saw was that the HMI, the infotainment system of a car, would go through this kind of cycle where it would crash roughly every 5 hours. Now, is 5 hours bad or good? Well, it's obviously not good, but that 5 hours actually, it does come up eventually, and probably sooner than you can imagine. The reason being is that these kind of, the cars are never actually quite turned off completely. So let's say you come back from your daily commute and you put the car into park and you switch it off, but obviously it's not actually completely switched off. It will be sort of in a hibernation state and retain actually its in state, so that when you come back to it and you resume it, it will pick up where it was. So that 5 hours, that could come up in a few days of driving. And that kind of brings us into a next category, suspend to RAM and sleep issues. So when you wake up that car, when you come back to it and you press the power button and the car resumes, that's actually a rather tricky engineering problem to solve, that everything comes back online as intended and as quickly as possible. So, for example, this one particular case that we saw was that the Bluetooth stack of the car infotainment system would not come properly online always. And that meant that when you go into the car and you press the power on, it would not automatically connect to the phone as intended. Not always. Now, a bit about performance. So, not all of these kind of stability issues are something that just fails. Sometimes it's, features that get a bit worse over time, a bit more kind of unpleasant to use. Performance is typically one, the way we kind of tend to see this. So specifically, the performance of the UI. I mean, response times, frame rates, launch times. So this example right here, this lovely chart, shows the launch times on the infotainment system of a certain action. That on the initial state, that takes about 200 milliseconds. So the y-axis is launch time in milliseconds. And eventually, once the system is used and used a bit more, it will grow into 600 to 1,000 milliseconds of time. And this is kind of tricky because these things are not easy for us human beings to observe. So if it gets a bit slower over time, it kind of can easily go unnoticed. You might feel that it's not as rapid as it was when you first bought the car, but especially when you compare the initial state to the state of where it ends up in, you can clearly see that the other system is quite a bit more sluggish or slow to use. Last of these categories, random or seemingly random crashes. I say seemingly because they're not really random. They're dependent on some kind of internal state in the system and variables that they happen to be just right, and then bad things will happen. And these are actually rather tricky to not only to catch, but also to resolve, because if you can't reliably reproduce it, then it becomes a bit more difficult on actually to catch it and capture data and work through it. This is actually a good example of where our system and our solution show its strength, because we try to capture as much data from the problem and before it, so that the developers can get to fixing it as soon as possible. All right, that covers the kind of the categories part. What we kind of try to advocate to our customers is to sort of shift left on the finding of these defects part. So let's take an example of a kind of a naive kind of infotainment development process where you first develop the system, and then you go into fleet trials, and then you discover defects, like the ones that I just described. So what we would like to see more is that this kind of discovery phase would start earlier. So you would start, if you discover these problems earlier, that gives you more time to fix these problems as well. And that typically yields into higher quality software that is delivered in a timely manner as well. The way we see this is easier to deliver is, as part of our solution, is to do more this kind of long-term testing already earlier on in the R&D phase. So I'm talking about stability and performance analysis in a lab environment instead of being done on kind of, or relying on the data you get from the fleet testing phase. Having said that, we do have a telemetry solution as well that synergizes really well with the data from the lab environment, because you can kind of cross-examine issues that come from the telemetry side with the data that you get from the lab environment side to quickly kind of look into what's causing these issues. And you can also take this kind of setup on the road. But I'd like to emphasize that part too, to start early on and start that long-term testing early on. So this is a key selling point and a key benefit of our offering is that all of this data from the stability testing and analysis phase is explorable and approachable by all to a dashboard. So all the data gets collected there and then aggregated into different kind of views. So the management gets a very high-level trends of what's going on, where is it headed to, how are different versions comparing to others, and then what are the kind of the burning issues that you have remaining and what are the impact of those issues. And then naturally the developers can use that list of issues and drill down into kind of minute level data to understand what's actually going on inside the software when something bad happens. Now this all kind of leads into kind of a rapid cycle of discovery, analysis, fix, and verification. And the faster you can make that cycle and the more easier you can repeat that, the faster you can get into good product quality in a timely manner. And not to mention that the dashboard, the fact that the data is kind of centrally available in a repository, that does enable different teams and organizations and suppliers to work together on a common problem to deliver results faster. Now there's a lot of positive impacts I can see our offering usually makes, but I'm going to focus here on the quality awareness bit. Having knowledge of what is the quality of your product, your infotainment system all the time, it really reduces the uncertainty of you don't know what's going to happen when you release it, when you release the car or when you push the over-the-air update. And that risk mitigation is usually what our customers tend to have valued most. And that's it from my part. I will hand the floor to Marius here, and he will talk a bit more about in practice of how the various test suites are used and what kind of experience they have with us.
Cool. Thank you, Mikko. So glad to be here. I think everybody's kind of lazy afternoon. So I will start with the question. How many of you have seen real live an Android automotive car? Raise the hand. Very nice. If it is one outside, the Lotus is there, if you want to see one. If you want to see an infotainment system in a car, we have a booth here near our colleagues from Profilence, so please come over and take a look. So my name is Marius Mailat. I'm building software now since more than 27 years, and I'm a big fan of Android Automotive, and I turned the company in this direction. And yeah, a few words about us. We are now 27 years in the market, and we are very glad to be able to bring some of the cars outside with Android Automotive. And you can see Renault Megane E-Tech, one of our cars we released with our colleagues from Renault, but not only the Megane E-Tech, also the Austral or the E-Space hybrid, and also with our colleagues from Volvo Trucks on the Oxygen project. So these are examples of what we have done in Android Automotive. My talk will be a lot about Android Automotive and usually how we can release such a vehicle into the street, but going maybe a few steps more than everybody else is doing, because a lot of companies, they do test, but they do not test from end to end, or they do not certify their platform. So the platform we show here, it's a certified platform. It's a platform who is able to pass certification on CTS, VTS, and other type of certification. We started very early in the few years, in 2016, and over the years we added everything we think such an infotainment system should have inside, including over-the-air update, including App Store, including navigation, electrical navigation. And I have somebody who came today at our stand and challenged me that Android looks the same in all the systems and everything looks the same. And I gave this example because you can adapt basically the operating system as you want. You are not forced to use any patterns. And these are live solutions which are out there from us. So you are able to customize as you want. So when Mikko is talking about companies generating bugs and crashes, this is us, right? We kind of do that. But he also has slides where he was saying that before running the XTS, right? And I'm going talking about this XTS. What we suggest to all the companies when they release a new vehicle, including the colleagues from Lotus, is to run some of these testing suites. Not only test like with internal processes and maybe run some internal end-to-end test, but try really a complete certification. And when we talk about certification, we talk about the CDD, the compatibility definition document, where Google defines how certain applications must run in a certain speed sometimes, reaction time, expected behavior. And I will say, this is for me the first thing I will suggest. At least look over this document, take this in consideration. The second step is at least run a CTS over your platform and see how bad it is, how Google is going to compare you. Why you want to do this? Why the companies are now doing this? Because an OEM usually thinks, okay, it's like what I'm doing has nothing to do with Google, or I don't know, I don't want to do it to certify with Google. You get two advantages. First, you get a test suite which is all the time updated, is used by companies like Renault, Porsche, Ford, PSA. So they all certify their cars in the same way, so you can only benefit because with each new version you have new tests. This is, I would say, the minimum I recommend. Of course, going forward, doing the vendor test suite is very important because this will find out what type of craziness kernel changes, BSP, or other very low-level changes you have done, or maybe your tier one has done and black box it for you. So you get like maybe a black box component, you have no idea what they're doing. And of course, the last one, running the security test suite, which makes sense for a GAS release, Google Automotive Services. So this is how usually like a certification looks like, with a pre-certification phase, a certification trying to release. Now, you need at least to plan something like 1 year to be able to run this, because if you run some of these tests, you're going to have a big surprise that not a lot of things are working. And of course, running and passing a certification, then most of the application will be compatible with your system. So taking the media player, if you come at our booth and talk with my colleagues, they will demo you, for example, how our 22 media applications are running. They are all running perfectly. So Tidal, Amazon Music, Spotify, Deezer, ARD, they all work perfect because we follow a certain way of developing that media player, which is compatible with the way that the media player is offering its information. And then, because there are a lot of designers here, I intentionally brought a beautiful slide, which I really love, because the reason is to scare you, to give you maybe the reality check. There are 7 test suites from Google created, which checks each of them independently different parts of the platform. And of course, Google would like that you pass all of them. If you engage with Google in a Google Automotive Services contract, you need really to pass them all. If you do not engage, so for example, like the colleagues from Lotus, then you're not really forced to do them. But in this case, you cannot use the word Android. So you're not allowed to brand it as an Android automotive or even Android car. Yeah, so basically, you can run the CTS, the VTS, the STS, which is related only to security. You can run the old BTS, which is looking at different aspects in the platform, looking at the patches and so on. You can run the ART, the assistant, and you can run newly the drivable test suites. Each of these tools, they come with a lot of additionally verifiers, right? So the first one has, for example, the RIADL, which allows you to plug in the car and get data from all the parts of the platform, logs, crashes, everything, videos, and then put them together with your analyze. So you can see how the car was going, what type of sensor data, even the complete CAN metrics of the car, but all gathered in one big tool to analyze it, right? So going forward, how you should approach this, you should approach it by planning as soon as possible, making sure that you have the understanding of the CDD and what is behind them. There are quite a lot of requirements. And going there will just ensure that the developers and the companies who will develop application for a platform, they will be able to port their application from Polestar to Renault, to Ford, and to Porsche. Not only that, you make sure that when you migrate from one version to another version of Android, you have a clear understanding of the effort. We just did a migration from Android 11 to Android 13. The effort, if the platform will not be certified, will be a huge amount, right? But because we already have parts which were certified, not completely, but we have big parts which were certified, we're able to migrate much easier. And because we follow these patterns, we are able to make the porting of some application almost instantly, including media, which is a great example for this. Okay, so yeah, you run all these tests, and then what you get at the end, you get a lot of issues. So this is almost a real-type example. I changed the numbers and some names and so on and so on. But it gives you an idea that there are like 6,000 something issues. And some of these issues are issues like, for example, you get disconnected from Bluetooth, or the connection to Bluetooth is under 4 seconds, and so on and so on. And you have to take each this task and to try to fix it. So there are basically 6,000 very big bugs you need to solve. And of course, it makes sense not to run them at the end, and they just, this will be a craziness, but to make sure that you run it with every module. So the way we develop is each module in the platform receive an owner. We run the CTS per module, so if you are working on the launcher, we test that module, and you as an owner of that module, you get the problems which are generated. And additionally, if you don't pass the CTS, you cannot merge in integration, so your code will die there from day one because you do not pass the integration of the entire platform. And if you set up processes like this, then you are able, from the start to the end, to develop a almost compatible platform. So I have one slide, and then I will show the showcase with the Profilence. This is also an impulse for you. A lot of companies are testing how they want. On the Automotive, Google created the so-called CatBox, which is a suite of different tools in the systems, helping on different parts of it. End-to-end testing, integration of the vehicle testing, performance, memory, profiling, and so on and so on. I strongly suggest that you give up to your internal Python automatic tools, and so on and so on, and try to focus on something which is almost industry standard now. And I brought with me a video when the colleagues from Profilence look at our system, I think in October, September last year. Yeah, we were almost before CS, not really stable. Oh, I'm really sorry. Can you stop the music? Thank you. And then they were able to run on our system. It was an almost ready version. So we didn't have so many bugs, but still they were able to find a big crash in one of our products, which is electric routes. But I think they only found it after running like 14 hours of simulation. So, but it's still the case, you know. I will maybe drive until Spain. I will never do a stop. So, maybe some memory leaks will gather. But basically, what you see in the upper part is our Spark running through the simulation of Profilence. And also, maybe Mikko, you want to take over and explain here electric routes. This is the error, which basically caused the problem. And because the system was quite reactive, you don't even feel so much the crash because we were restarting very fast. The hardware was very powerful. So because of that, maybe the user only see like a downtime, a few milliseconds or a second of not responding, but still enough to see that something is wrong in the system. Yeah, and we are now running. on our booth, the Profilence, most of the time, the whole day, and the bug is gone. So we solved the problem. We didn't know that we solved the problem, but today we find out everything is solved. Thank you. Questions?
To either of us.
Sorry?
To either of us. Any questions to either of us?
Of course. Okay. Thank you.
All right. Thank you.